Now let us start with fuel cell, that is also known as H2O2 cell. Okay, so why are they used? Because they are way more efficient than that of the thermal power plant, where fossil fuels are burned so that the water could get converted into steam and thus the turbine could run and produce electricity, right? So also the thermal power plants are the major source of pollution. So galvanic cells or electrochemical cells are designed in such a way that the energy of combustion of fuels like hydrogen, methane, methanol, etc. are directly converted into electrical energy, and these cells will be known as fuel cell. Okay, and these cells, if the reactants are continuously supplied, so the product will be formed continuously. Okay, and fuel cell produce electricity with an efficiency of about 70%, and whereas the thermal power plant has an efficiency of 40% only. And if better catalysts are provided to the fuel cells, and so the reaction in the fuel cell, the reaction taking place in the fuel cell, can again give a further more good efficiency, and this is pollution free, used in many automobiles. And if we look at the structure of the fuel cell, so we will be having a anode and cathode, pretty obvious. Anode will be negatively charged, cathode will be positively charged. There will be three opening, hydrogen gas for the left hand side wall, then an opening for oxygen gas for right hand side wall, and an opening at the top of the cell between the anode and cathode for water. Okay, so anode and cathode can be like cathode is positive and oxygen is converted into hydroxide in the presence of H2O, right, and 4 electrons, while at the anode H2 gas plus 4 hydroxyl ion will give us H2O plus 4 electron. So the overall reaction is that 2 moles of hydrogen gas and oxygen gas will give us 2 moles of HCl in liquid form. So this is all about the fuel cell. Coming next will be our dry cell. Okay, so we studied about primary cells and secondary cells. Secondary cells are those can be rechargeable and used again and again, while primary cells, the reactions cannot be reversed and can't be used again and again, right? An example was dry cell and mercury cell. So here, coming to the dry cell, it is a battery, a device that will have one or more electrochemical cell which will be converting chemical energy into electrical energy, right? So here, taking the first example, that will be zinc carbon cell. So as the name suggests, zinc carbon cell, zinc will act as an anode and carbon will act as a cathode. Okay, so zinc, how come zinc is going to act as an anode? Because the container, the metal container in which the electrolyte and electrode is present, is mainly of zinc, and the base of the container will act as an anode, and the cathode is positively charged and made up of carbon, right? And the moist electrolyte paste is made up of manganese dioxide and low moisture electrolyte like ammonium chloride. Okay, so the maximum amount of voltage that can be produced by a primary cell, a zinc carbon cell, is 1.5 volt, right? And but this is not reversible. The half cell reactions will be two, that is the reduction reaction and the oxidation reaction. See, the ammonium chloride with MnO2 will get converted into Mn2O3, and ammonia with H2O, right? While in the case of oxidation, zinc will get converted into zinc 2 positive, leaving 2 electrons. Okay, so the overall reaction will be zinc plus manganese oxide dioxide and ammonium chloride will be giving us Mn2O3, zinc, NH32Cl2 plus H2O, right? Coming to the next example was our mercury cell, where HgO, that is mercuric oxide, will be serving as cathode and zinc will be serving as anode. At the anode, zinc plus 2 moles of hydroxyl will be giving us zinc oxide plus H2O plus 2 electron, while at the cathode, mercury oxide plus H2O plus 2 electron will give us mercury plus 2 OH negative. So the overall reaction is zinc plus HgO will be giving us ZnO plus Hg. Simple as that. Okay, so the two reactions were zinc carbon जो सेल है उसमें आपका ओवरऑल रिएक्शन विल बी जिंक प्लस मैग्नीज डाइऑक्साइड प्लस अमोनियम क्लोराइड विल बी गिविंग अस मैग्नीज डाइऑक्साइड प्लस वाटर प्लस जिंक NH3 whole twice chloride. Okay, and in coming to the mercury cell, overall reaction will be zinc will be converted into ZnO and HgO will be converted into Hg. Therefore Zn plus HgO will be giving us ZnO plus Hg. Okay, so coming to the very last topic of this chapter is corrosion, the natural tendency of conversion of metal into its mineral compounds form on the interaction of environment. That can be polluted air, water, or some other associated metal. That is what known as corrosion. Okay, so iron gets converted into its oxide, that is Fe2O3 hematite. We know about it from the tender classes, right? Copper converts into carbonate, that is malachite, that is CuCO3 dot CuOH2. Okay, then silver converts into sulfide, argentite, right? That is Ag2S. While corrosion of iron by conversion into iron oxide is known as rusting. This is a very common question, right? And corrosion of silver is into the sulfide is known as tarnishing, right? So iron, hematite, copper, carbonate, silver, sulfide. Okay, what is the mechanism of corrosion? If we take the case of iron, oxidation occurs, iron solid gets converted into Fe2 positive plus 2 electron, while in reduction 2 O2 negative plus 4 H positive will be giving us H2O. So therefore the atmospheric oxidation will be 2Fe2 positive plus 2H2O plus half
Till
of
then,
oxygen
bye-bye.
gas will be giving us Fe2O3 plus 4H positive ions. Okay, so if we see about the electrochemical corrosion, so the corrosion may be chemical or electrochemical, right? But the anodic dissolution metal under the condition of corrosion will be like M will be converting into Mn positive. Okay, and N number of electrons will be released. Okay, pretty simple. M getting converted into, getting oxidized into Mn positive, and Ne, N number of electron are released. Next will be our prevention of corrosion. Okay, so the main principle underlying the method of prevention of corrosion is to separate the metal or isolate the metal from the environment so that corrosion couldn't happen. So it can be by painting the metal, then alloying the metal, right? Then as far as possible we can prevent any other metal surface to get contact with that particular metal, then covering by some chemicals such as bisphenol, then covering the surface by other metals such as zinc, that is the process is known as galvanization, or antimony, right? So that they can save the object. Or the sacrificial electrodes can also be used. Those are those metals which corrode itself but saves the object on which they are placed. With this we are done with this chapter. Bye bye. Do share, subscribe, and comment.
Goodbye.